Hi to all. So in this video we will cover the modified internal rate of return. Before we start with the modified internal rate of return, I would like to show you visually in a chart what or how the net present MPV profile of a project looks and how we can visually identify the internal rate of return. This is going to be helpful, right? So now let's assume, let's say this cell, we want it to be equal to the net present value, which we have here. I mean, here we have this formula, right? Okay. And now let's change the, let's try a pool of different discount rates and see what happens. And we will start with 0% as a discount rate. So in that case, if you add up the future cash flows, that will be exactly the same. It will be exactly the same as the present value because the discount rate is just zero. And then let's start increasing these rates by 2% or by 1%. Okay, so we can have 1%, 2%, and we will continue. Let's give Excel all of these rates until 20%, right? And now let's prepare this data table. So what we will do is we will have Excel calculate for us. So we are making reference to this cell where B12, where we are calculating the net present value of this project. And we will have Excel recalculate this considering each one of these different discount rates rather than the 8.09% discount rate we have here, right? Okay, and we do this by selecting this in data, what if analysis data table, and then the column because this is a column. And then we are telling Excel, I want you to change this cell and I want you to try all of these values I'm giving you in this left column and try one by one in this B2 cell and then give me the net present value, right? So we do this and now we have the net present value. Now I'm going to plot this. So I'm going to insert this scatter and there we go. That is called, this graph is called MPV profile of project um, X. Okay, so there we go. Now, it is not a the IRR. Another way of thinking about IRR, because we know we have here that the IRR is that rate that makes the net present value zero. So here, what we are doing is here in the x-axis we have each value, different values for the discount rate, and then this we are plotting the value of the NPV when we use these different values of the discount rate. Now, IRR is right here. Is that rate that makes the net present value equal zero. So if we look at it here, right, as we increase the rates, this number is becoming is getting smaller, smaller, smaller until at some point when we get to 9%, it is already negative. We already know that 8.09, if we try this one, right, we have, or even we would need a little bit more of the decimals. Let me look at this. We had calculated this before, 8.08927. So if we try here 8.08927, right, it's very close to zero, so that's the point in which the net present value becomes negative. Now, in a conventional project, right, and by conventional project, I'm going to type this here, in a conventional project with one initial cash outflow followed by future cash inflows, there is as only one internal rate of return. As we can see here, there is only one point in which this net present value, and in which this line intercepts the x-axis, which is a fancy way of saying that the net present value becomes zero. There's only there's only a single rate, there's only one rate that makes this true, and that is the IRR. However, and now I'll move to this other cash flow, we also have other kinds of cash flows where that are not conventional. When a project is not conventional, uh, there are cash outflows in the future. Don't quote me on that definition as is, but that's the intuition. Then it is possible to observe more than one IRR. Now let's see this visually. I think this visual approach will be very helpful in understanding what is going on. Uh, and then let's look at this. So we will repeat the same thing. Here we have a series of cash flows. Now I believe I don't need to discount each cash flow one by one by one by one by one, because you can watch the previous videos. We have a shortcut in Excel, using Excel shortcut, right? Not shortcut, shortcut. There we go. Now it's fixed. And so we will say NPV, we will use the discount rate, and then all of the future cash flows, keep this in mind, right? And then we will add this initial cash flow. So the net present value is negative here, but now let's do this. Let's do the same thing we did before. Let's reference this NPV calculation here, and then let's ask Excel. And now we're going to try a, a wider uh, range of discount rates here, just to make our point. Now, let's create the same data table, whatever analysis data table. So basically, we're asking Excel to calculate the net present value using this formula, which we are referencing from B7. But then in a column, we want Excel to use all of these values one by one, replace this discount rate, recalculate the net present value with this formula we are referencing here on the top, and then give us these values. Now we have the something similar to what we saw before, but I will just plot this. I don't need to plot the whole thing. I think I can plot until 100, scatter, plot this. And this is how the net present value NPV profile of project Y. This is how it looks like. Now, before, the definition of IRR is such a rate that makes the net present value equal zero. Hey, guess what? We have more than one IRR in this case. So when the cash flows of a project are not conventional, the project is not conventional, it is possible. This is possible. And so we identify, well, this is happening. I have already solved this. So I know it's around, when the discount rate is around 50 something, 53 point something, then this becomes an internal rate of return, NPV 0. And also when the discount rate is 5 point something, we also have an internal rate of return. So we have two internal rates of returns, right? Okay, so let's look at this. How does Excel handle the internal rate of return function we just learned in this case? Well, easy. We just use IRR. Now, by the way, if we use the data, the goal seek, the way we did it before, it will work. We want to set this cell to 0 by changing this one, right? and yeah, it gets a solution, but we are ignoring that there's more than one solution. So let's take this back. How can we can use the internal rate of return command in Excel we used before in the previous video, IRR, and then let's keep in mind we just give Excel all of the values, but then there is something that Excel asks and we ignore it before. Guess. So in this case, we take a guess. Let's say I think it's 4%. Excel will give us the internal rate of return that is closer to our guess. But now let's solve again. Let's give Excel all the values. But let's say I think it's 60%. Then Excel will give me the internal rate of return that is closer to my guess. So that's why we have a guess option here, and we can give Excel our guess. So when there are more, then when there's more than one internal rate of return, then Excel will give us the one that is closer. Now, in this case, the solution, is there a solution to this problem? Which of the IRRs is the actual IRR, right? Well, in this case, we instead use the MIRR, modified internal rate of return. So we're gonna follow the following. We're gonna follow these steps. The first step we'll follow is I have the data table there. Okay, so the first step we'll follow is let me move this here. Okay, the first step we'll follow is let's get the present value of the cash outflows. Only the outflows one by one. Let's take the long approach first. Okay, so we know how to do this cash outflow, this one, and we get the present value. So one important thing is this cash flow in particular is happening in time 0. So it is already in present value. I can just keep it like that, but if somebody is if somebody's sort of becoming confused, okay, divided by 1 plus the rate to the power of time, because the power of time is 0, then this becomes 1, the denominator becomes 1, so we end up with the same $200,000 negative. Okay, now cash outflows. We do not have our outflows here, but we have an outflow here. So we get the present value because this is an outflow. We get the present value again. So this divided by 1 plus the rate, right, to the power of time. Let's keep in mind, if anybody's curious, you can also use PV, right? The PV command, and you give the rate, then the number of periods is 5, and payment is 0, then present value is this, and type is 0. And if we do that, we get the exact same number, but I will just delete that to avoid any confusion. Okay, that's an alternative way of doing things. Now, second step. Now, first step, we're done. We have gotten the present value of each one of the cash outflows. Now let's get the future value of each one of the cash inflows. Now, let's keep in mind, if we are looking at the first one of the future cash flows, this is 170,000. So we want to take this to future value to the terminal period. The terminal period is 5. So how many periods into the future do I need to move this cash flow, right? Well, we have, let me see if I have something I can use here. Um, okay, so if we're already in period 1, we need to move to period 2. That's one period. Period 3, another period. Period 4, another period. And finally, we get to period 5. My whole point about doing this is It's just 1, 2, 3, 4 periods, not 5 periods. Why? Because we are already in 1 year from now. Okay? So how can we do this in a clever way? Like in a clever way, I mean in a using some shortcuts. Well, we just take this terminal period, which is 5. You can lock it, F4. And after you have locked it, then you just subtract this one minus the period you're already in. This second period, this latter period, you don't lock it. You just lock the terminal one, and then you get a 4. Then you can scroll this to the right. 4, 3, 2, 1, and if we continue, we would end up with 0, right? Now, these numbers are important because these are the period of time we will use when we are working on this second step. Now, let's remember what was the second step. Second step is getting the future value of the cash inflows. So we will get the future value of 170,000 multiplied by 1 plus the rate. Let's lock this rate now to the power of time, because we lock the rate and we are referencing the time which we have there on the row on top of our formula. Now we can just scroll this to the right and we get the future values for each one of the cash flows one by one. Keep in mind, somebody is interested, you can also use the FB command, but I will not get there to avoid any confusion. Now, once we have done step 1, step 2, we have the present value of each one of these cash flows, and we have cash outflows, and we have the future value of each one of these cash inflows. So what we do is we add them up, outflows, and we add up all of the inflows. So the outflows, this one plus this, we end up with this much. And the inflows, we can use sum because we have 4, and there we go. Okay, and now we can use this formula of the compounded annual growth rate, which is basically this future value, right, that we calculated divided by the present value. Once we do this, we raise this to the power of 1 over n, which is 5 in this case, and then minus 1. And of course, one thing to keep in mind, in this formula, we're solving this manually. So when we add up the, the, the present value of outflows, we want to keep this number positive, right? And there we go. Now we have this MIRR calculated here. Then another way of doing this is using the rate command, and this one I will use it here. And the number of periods is 5. Payment, remember payment is for annuity, so here we don't have an annuity. Then what is the present value? Now this is the tricky thing. In Excel, present value, we need to plug it as negative. Whenever money is coming out, it's negative. Whenever money is coming in, it's positive. In your BA2 plus calculator as well. In our previous calculation here, we do not use it as negative because this is the same as working with by hand, right? Like you take a pencil and a pen and you're solving this on a piece of paper, then you don't use these negative signs. But now that if we're using this rate command here, we do need, okay, once again, rate number of periods. The overall is 5. Payment, we're not using that, but payment, we need to plug that as a negative, future value as a positive. The rule, remember, in Excel and BA2 plus calculator, if money's going out of your pocket, then that's negative. If money's coming into your pockets, that's positive. And then type is 0, and guess, we're not taking a guess, right? And we're getting the same thing. Okay, and this is no longer a simple rate. This is now the MIRR because we have taken these two first steps before doing this, either with Excel, using Excel, shortcut for um, FB divided by FB divided by PB to the power of 1 over 5 minus 1, right? Now we can take a shortcut where Excel will do everything. And now The important thing is you know exactly what Excel is doing, and this is MIRR, and then you will just choose all of these values. The values, let's remember the values we had in the very beginning. You just choose all of them. And then Excel is asking about a finance rate and a reinvest rate. We are assuming that both are the same, both are simply the discount rate. So we are assuming that our discount rate is 4%, and we are also assuming that those cash inflows we are receiving are reinvested at a 4%. We could vary that later on, but that's not in the scope of this class. And there we go. So we end up finding that the MIRR formula is just confirming that our calculations are correct. Okay, so basically this is the modified internal rate of return, and I think we have calculated this. We know why we need it. We need it because some projects will have multiple IRRs, more than one IRR, more than one points in which more than one discount rate that will make NPV equal zero, more than one IRR. And in those cases, we're puzzled. We're not sure which of the IRRs we should use. So the MIRR, the modified internal rate of return, resolves these problems, and it only gives us a single solution. Okay, so now you know how to get the MIRR. I hope this was helpful. Thank you for your attention.